and welcome to the new session of this video. And this is an entirely new thing that we are talking about the molecular point group for the first time. So far we have been studying symmetry elements in operation. Now we are entering into the molecular point. We have learned that water molecule has four symmetry operations and it is said to belong to C2E point group. This is generally known to all of us. Then how have we reached to this point group? How have we assigned the C2E point group to the water molecule? So assigning a point group requires a method, requires a systematic procedure, requires mathematical tools, or simply by correlating structures with one another. The symbols that we use in symmetric groups are called as Schuriefly symbols. In this video, we are going to get familiarized with the symbols and will proceed for systematic identification of molecular point group. And in later sections, we'll be looking for alternate methods for recognition of point groups and further the examples related to the point group. So, be ready and let us first start doing a practice where we'll start with identity. We'll add up more and more elements and we'll reach to the highest order axis, highest order symmetry in the molecules. So let us begin with first identity. Identity is the case where the molecule is the most ugliest one. It looks totally symmetric. It has no symmetry at all. Point group assigned for this is C1. If we add sigma to identity, it goes to CS. The name of the point group is CS. Adding I to identity gives a new molecule with a symmetry called Ci. And identity and only rotation exist. The point group assigned is Cn. Along with the identity, if Sn exists with n is even, the point group assigned is S2n, and if n happens to be the odd, then collecting some other elements also, it goes to CNH. We'll see this in the later case. In many molecules where identity and the rotational axis exists, and along with the vertical planes of reflections are there, such point groups are referred as CNV point groups, and these are the most common situations where we find such point groups. Further, adding horizontal plane to these rotation and identity gives a new system that is CNH. If we are talking about ECN and C2 is perpendicular to Cn, the point group is Dn. However, if it does have a horizontal plane of reflection initially, the point group would be DNH. If there are C2s and the dihedral planes instead of horizontal planes, then the point group assigned is D and D. The case of linear molecules is very typical. If identity and C infinity axis, that is possible only for linear molecules, then point group assigned is C infinity V, and if it happens to be symmetric with respect to center of inversion, then it is known as D infinity H. So in this case, we'll have C infinity axis and center of symmetry. Finally, with the higher order axis and large number of symmetry operations, the molecule would be assigned as tetrahedral, TD, octahedral OH, isohedral IH, etc. So this is one method of assigning the point group. You start with the bare identity and then go on adding more and more symmetry operations and coming up to some conclusion, defining some property of symmetry. However, there is an alternate method, a systematic method to identify the point group, that is using the decision tree method. This is the method where you keep on asking some questions and you then answer yourself. Say, how do you do it? Let us start. Well, first ask the question whether the molecule has a special geometry. This is the question, and the answer to this is possibly to yes or no. If we say yes, then we ask ourselves, is it a linear molecule? That too without I, that it does not have center of symmetry. The point group assigned would be C infinity V. We have studied just now. If it does have a symmetry of point of inversion, it is linear, point group is D infinity H. And then additionally, if we have a molecule which is tetrahedral, the point group is TD. If it is an octahedral, point group is OH. And if it is icosahedron kind of molecule, TBB kind of structure, then it is referred as IH symmetry. So if molecule has a special symmetry, then you need not bother about symmetry properties of that particular molecule. Simply ask the question yourself and get it justified. But if it is not a special geometry molecule, then there are several questions that come into our way. We ask then, does it have a CN, rotational axis? If the answer is yes or no, here I'm talking about no. If it doesn't have a CN, and if it does not have a CN, then I ask you whether it has a sigma H horizontal plane. You say yes, point group is CS. If you say no, then further question is there is an I, center of symmetry? If you say yes, the point group is CI, and if you say no, the point group is C1. So you just see here that C1, Ci, and Cs are the molecules of low symmetry. Now, additionally, if the answer to this question is yes, then the next question that arises, does it have an S2N, an I only, that is collinear with the principal axis? And if you say yes, the point group is S2N. If you say no, the next question that comes up is then in that case whether NC2s are perpendicular to CN. That means if there is a principal axis CN and there are n number of C2 operations, are they perpendicular to each other? Of course, the answer to this question may be yes or no. If we say yes, the point group might be sigma H, or rather is sigma H. If sigma H is present, then the point group is DNH. If you say no, then additionally I ask you a question, does it have sigma D? You say yes, then point group is DND. You say no, the point group simply becomes as DN. So DN are the molecules of intermediate symmetry. Further, if you say no, no means NC2s are not perpendicular to CN, then the molecules are not flat. You further ask, does it have a sigma H? In case your answer is yes, the point group is CNH. In case if you say no, then you are further given a question, does it have a vertical plane, sigma V's? You say yes, the point group is C and V. If you say no, then the point group is merely C and. So this is how we identify various molecules in terms of their symmetry properties. Keep on asking your questions, and then depending upon the answers, we move on to different possible options. Thanks for watching this video. See you in the next case. Thanks.